Hi everyone, I'm pleased to meet you. I'm happy to speak to you today. As you heard, I'm here from Wrocław. I work for Ocado, and I will talk to you about boilerplate and Scala language, and ways to use Scala to make concise code. But to get started, what is boilerplate? Do you have any rough idea? Have you experienced boilerplate ever? Raise your hands. Okay, and so what is a boilerplate? Basically, it's a code that you have to write, but you don't want to, right? So if you gotta look for an example, do you recognize this kind of pattern? Have you ever used HTML? So basically, each HTML document begins with bloated piece that nobody understands, but everyone has to use it because browsers, right? And if I were to characterize the boilerplate, how does it look like? What are the key points to make a boilerplate? Well, you have a thing that is repetitive. So you have to put it all over the place, all around, like types in some languages, stuff like that. It sounds unnecessary. I mean, it wouldn't compile without the boilerplate, but it's not necessary to express what you want to express. So your business logic is somewhere else than in this boilerplate, right? And basically it's a burden. It's something you would prefer to avoid, but you need to use it just to proceed with implementation, right? So the general feeling would be that boilerplate is something we want to avoid. Is that correct? More or less. But can we? Well, let's give it a try. And yeah, today I will show you some tips and tricks from Scala that we use daily to make the code more brief, more concise. And there is a disclaimer for the beginning of the talk. I'm not claiming that one language is better than the other today. I want to discuss certain design decisions made by the authors of Scala that make the language just concise and fun to use. So Scala, do you know Scala? Any of you? Raise your hands. Okay, I'm surprised to see so many hands. That's nice. Any other languages like Java? Much more. Python? JavaScript? Okay. So we know different languages and we have different problems with different languages, right? Scala is, compared to the others, like to Java, to JavaScript, it's kind of new language designed in 2004 by Martin Odersky, who had a chance to cooperate with people designing Java, and he had his input when designing generics, for example. So this guy had some previous knowledge on designing languages, and he and his team used this experience to make things even better. And today I will show some of the comparisons between other languages and then proceed to things that are specific to Scala that you can use to make the code look nice. But what's Scala anyway, for those of you who don't know it? Well, it's a language that is designed to be both object-oriented and functional. And I don't mean that you can do both, because you can try doing functional in, for example, Golang, but whoever tried knows that it's not the best experience you might have. It's designed to be capable of doing both. It's designed to be concise, to be very high-level language. So, for example, you have the ability to use the type system a lot and express a lot of your intentions on the type level, for example. It's statically typed, so it's unlike Python or JavaScript when you can assign a variable of type string and then change it to int. If you once decide for type, then you have to stick with it. It runs on many platforms, so it was designed for JVM like Java. But today you can use it with JVM, you can compile it to JS and run it on Node, you can compile it to native with LVM as well. So plenty of opportunities to try different platforms. And to see how it helps, let's start with the basic example. So think you always do to say that you know a language, let's write a hello world. So let's start with Java. If I were to write hello world, it would usually be something like this. So there definitely is a print line, and some additional code around it. But my intention was to print line, right? So print a line, hello world. But there is a lot of things that happen around the place, like public, void, static, something. This wasn't my original intention to write that. I wanted to write hello world. So we can identify some boilerplate here. Now moving to Python, it's much shorter, right? Some would argue that the code below is not necessary. If we wrote print a line, basically it would work. So it can be even shorter. And if we were to do this in Scala, and I mean Scala 3 because this is the current version, it would look something like that. So it's not as concise as Python is, but it's much more concise than Java. So we're getting somewhere. But even here, you have to write some def, some annotations, so it's not perfect. And in this presentation, there is not going to be any like silver bullet. This is not a solution for all of your problems. This is just showing of a different approach. Which one did you like the most? First one?
It can be shorter.
Yes, I know. It was intentional. Second one? Okay, the third one? The same people? Okay, never mind. So let's move to something serious. Do you have pets? Okay, at least one person with a pet. Great. So what does a pet have? Like a name and an owner? Could be enough. Let's take those two and design a data structure that will describe a pet. So starting again with Java. I know this is not the newest version. You can do something like record types and it would be much shorter, but in general, in what you see on production, it would be this kind of stuff that you meet usually. If we were to use Python, it would be something like that, assuming that name and owner are private properties. And in Scala, you would use something we call case class. If you're familiar with Kotlin, it would be something like a data class. And in newer Java version, it would be something like the record type. Yeah, so compared to the first slide, it's much more concise. And it's intentional that I use this quite long example because I want to show the design decision. So initially, in the first versions of Java, this was the only way you could do something. And initially in Scala, it was like designed with this in mind. So I just wanted to show like the design decisions made by the people who created the language. So if you compare Python and Scala, then you might think maybe Python is shorter because we don't have to write those strings here and there. So maybe the problem are types. What do you think? Are types the reason of boilerplate? No. That's also my argument because if you use Python, for example, and even if you use typings to annotate that you want something to be of a specific type, you can still do something like that. So we create a pet that has some name, but then we override with the number. And the language and the compiler, then they cannot help us and tell us that we are doing something nasty, something wrong. This will end up in a production incident at some point if we are going to do things this way. So I would claim that types are not boilerplate, but sometimes the way the language uses types or is designed for types makes it like burdensome. Sometimes you have to annotate types too much, for example. And we will get to the point where I will show you how Scala handles that as well. But before we go there, I want to show you one more thing. So types sometimes sound like a burden, but I will show you a counterexample. So please welcome refined types. Anyone knows the word? Okay, few hands raised. Perfect. So yeah, let's imagine for a while that we are designing like an e-commerce system. In e-commerce, there are users who place orders, and what we are about to model now is a piece of the order. So imagine that an order has an ID and a set of lines that represent a product and the quantity, okay? So if we were to write it in Scala, and I know this might not be very familiar, but bear with me, we could start with something like, I have a product, so let's say it's a string, like a product name or product ID, whatever, and the quantity that somebody ordered. Like initially it makes sense, right? But then, even with type system, you can do something that doesn't make sense in a business way. So for example, someone might order a product that is not named or has no ID, which doesn't make sense. Or even worse, someone might order like negative amount of bananas, for example. And how do you handle that? Well, if we were to make things right, we would have to do something like that. So a smart constructor, it would then verify if the product is empty, if the quantity is less than 0, throw some exceptions, then you have to handle them. The complexity grows, right? And also, apparently, we had to write some code. Yeah, basically it's our job, but writing code, me personally, I'm a bit lazy. If I can write no code, then it's even better than writing some code. So can we get rid of it? So with refined types, you could implement the order line this way. So there is no code. You can see that the string product and quantity int have changed to non-empty string and to positive int. So basically in Scala you can have those additional requirements on the type level that you can place to express your business intention. So I want the product to be non-empty and I want non-negative or positive amount of the product, right? And I didn't have to verify it because the type system takes care of that. So as you can see on the bottom, we can produce the valid order line, but if we try to place like an empty string or a negative value, it will not compile. And if we were to proceed with this example and model the whole order, then we could, for example, say that order has to be like valid UUID, which is just a shape of the identifier, and say that we want non-empty list of lines. So we don't have to write the ethology for checking if the list is empty and stuff like that. So we had to write no code that is going to be executed on the runtime, and the compiler will do the job for us. And it will help us to identify if we use the code in the wrong way. So if we try to provide an empty list or just a type of a list that can potentially be empty, then it will yell on us and it will not compile. So yeah, we have the compiler to verify things for us. We don't need to write code on our own. If we did not write a code, like a business code, then we don't have to write tests either, so even less code. And then this is an advanced feature, perhaps, but if you have like ends of the system where you accept JSON, XML, or read from database, you can also apply this type level verifications, and you don't have to write the code for the decoders either. It will just infer the assumption about the types. If you have further questions about that, we can just have a Q&A afterwards. But to be aware of time, let's move on. So this is one of the things that you can do with the type system. We don't have the burden of using the types, but we use the types to avoid writing code. So that's nice, I guess. But then moving on, I said that types are not the reason of boilerplate, and to account for that, we can talk about type inference. This is a thing that it's not like specific to Scala. Modern languages do that, and just to show you how does it work in Scala. If you were to write a list, assign it to some variable, you can usually avoid writing the type declarations on the left-hand side. So the compiler will infer the type for you based on the shape of the data. So we didn't say anything about the inner type. It just had a look that we have integer, integer, integer. So the common type is integer. Then we have a list of integers, basically. It's nothing extraordinary. Then it also works for more complex types. So imagine we have a list or a map of city standard coordinates. If we were to write it like this, it's an equivalent. So we don't have to write the string, the tuple of doubles, because it's unnecessary. The compiler can guess it, right? And Scala compiler is quite good at it. It can infer a lot of things. Function types, stuff like that, you can also infer that as well. So we have refined types to express precisely what we intend to do. We have the type inference to avoid writing the unnecessary types that we don't want to write or don't need to write. The other thing we can use in Scala, and we use it very widely, is pattern matching. So, do you remember those switch case statements in your languages? They are usually, you see them in the book where you learn about the language and then nowhere else, because usually you would use ifs. So not in Scala. In Scala, it's actually is a very powerful control structure. And the very, very simple and dummy example would look like this. So say you design a function and you want to convert integers to strings in a specific manner. So what you could do is take the value, then write match, and say about the cases you're interested with. So you have the case, in case the value is 1, then I want to produce something. In case it's 2, I want to produce something else. And then in all other cases, so the underscore, you can think of it as I don't care. Anything there will be, I will just take the other side, right? And yeah, it's not sophisticated. We could do it with if-elses. We could argue if this is more concise or more readable than the others. But this is just to get familiar with the syntax. Let's move on and have some more complex example. So we're going to match a list. And this on the other side is just to showcase the syntax as well. And I know it looks kind of complex, but bear with me. So you have a list on the input. We match it against certain patterns. Let's go one by one. So the first one, we want to consider a list that has very specific values inside. So it has 1, 2, 3. In case we have this specific list, we produce 1, 2, 3. Then the second case is somewhat different because it describes a list that has a first element of 1. Then this is just another notation for a list. So each element combined with double column. We have a 1, 1, 2, 3, 5, Fibonacci, right? Sounds like Fibonacci. And again, we have this underscore here. So we say that if the first couple of elements match, we ignore the rest, and we produce the output that starts like Fibonacci. Then we can also place another, we call those guardians, like if statements, to execute some additional code for the verification. So we say that anything it will be, as long as for all elements we have the element greater than 0, we can claim that we work with positive numbers. And then you can see that we have placed the whole list in another variable and then did something with that. We can also extract a piece of the list. As you can see with the x, we can have a list that contains 9, 9, and an x, whatever would it be. Scala basically at this point assigns the value that's there and allows us to use it on the right-hand side. And also we have this case, anything else, we produce another thing. Why do we do this case underscore previously and now? What do you think? Any ideas?
Because each expression needs to return some value.
Yes, because it needs to return some value, right? Because what would happen if I didn't handle the other shapes, right? I need to be certain that I handled all the possible values, because otherwise it would be an exception, right? Because we didn't match the certain value, and the compiler is able to tell you didn't sufficiently cover the matching. So unlike other languages, when you do some ifs, it will not tell you, well, you did those two ifs, but what if the value is not something? With pattern matching on the type level, the compiler is able to tell you that you didn't cover some cases. So we have refined types. We have type inference. We know something about modeling the data. I would like to propose one more exercise to model the pet a little better. It wasn't the best model, I would argue. It was lazy. But let's move to something better. So in Scala, we often work with something we call algebraic data types, and it sounds complicated, but basically you can think of enums. So you can have a data structure that models an animal, and there are certain implementations. You can have a dog, cat, horse, snake. Some of them just implemented with a name. Some of them have additional types to them. Some of them can even implement it with fixed value, right? And the common thing we're going to do in like a functional fashion is to design a data structure that is like encapsulated within one place, but don't place any logic around it. So in the object-oriented world, you were usually thought that you should like create an animal, then the animal is capable of walking, talking, flying, whatever, moving. And those would be like the logic certain for the cat, for the dog. Sometimes it would be inherited, but in functional programming in general, we would separate those two. So for this kind of data structure, we could implement like an algebra to interpret this algebraic data type, or just a function that consumes this kind of type, whatever naming you prefer. So let's design a function, considering everything we know about Scala right now, that takes a list of animals and will produce only cats whose name starts with an A, and snakes whose length, because snakes have a length there if you didn't see it, that have a length over 1.5 meters. So if you were to do like short thought experiment, how would it look like in the language of your choosing? What would that be? We would initialize like an empty array, then do for over the list, then check by an if we have a cat, if the name starts with an A, or if we have a snake, if the length is certain, then put those kind of animals in the list and then return the list, right? So the piece of code. And yeah, this is intentionally selected example, but in Scala you can use the power of pattern matching and all the stuff we saw to make it very short. So basically we work with these animals, and there is a nice method called collect on collections in Scala. It basically takes a pattern match, and if the thing matches, it will take the value from the right hand side. So we only want to take, first case, cats, if the name starts with an A, right? So we take the cat and place it to the list. Or snakes that are called whatever they called, we don't care, so we put the underscore, and we check if the length is over 1.5. If we were to look for a certain name, we would put the name here. If we were looking for a certain length, we would put the exact length here. But since we only check if something starts with something or is greater than, we use the if. And we select this kind of data. So if we were to test it over this randomly selected set of animals, it would work perfectly. It just selects cat named A and snake Python, and I'm not very creative with the names, right? Yeah, if you have any questions, we can have a Q&A for the code. We can go back to that. But there is one more thing that I would like to show you that Scala syntax allows you to do. Modern languages tend to do something like that. And this is extension methods. So imagine you have a library that you use, or a standard library, and you would like to extend the API. Avoid doing like wrappers on your own, but you would like this specific thing. For example, on the list of ints, you would be very happy to have the list of only odd numbers, for example. And usually what you would have to do is to write a function that would take this custom type of somebody else's and then modify it somehow. But then again, if it's a more complex example, you have somebody else's API, maybe it's a private thing, it doesn't get a nice. But in Scala you have those extension methods, and there is very neat syntax for that. So basically we say that we want to create an extension for a list of ints, and the extension adds a method that produces odds. So basically it filters the original list and checks if the modulo 2 equals 1. If we were to use it, it would look something like this. So we have this extension method in our sources, then we have the test data, so this is a list of integers from 1 to 10. And if we were to produce odds, so you can see we call the odds basically on the list. We don't have to wrap it around with any other function. The output is, here, and it looks like like this. Sorry for the skipping. And we wanted the thing to only work on ints. So if we were to call it on strings, for example, so we have a list of strings that have some numbers, we would expect it not to work, right? So the compiler obviously yields at us that we made the mistakes, but also it's kind enough to say that there is a method odds, but to apply it, you would need to have a list of ints opposed to list of strings. So basically, it can point you in the direction of what you may have done wrong with the type, right? So this is about the extension methods. So just to recap what we have learned, we have compared the languages and saw different strategies for doing things. We have saw that types are not necessarily a boilerplate, and they can be even used to reduce the amount of code you have to write. We saw that type inference can also help you with that. We saw the power of pattern matching, and this is something you might, if you want to learn Scala, I encourage you to try playing with, because it just looks nice, and it's just a new way of doing things. We have learned about extension methods, and there's plenty more. So Scala is a very rich language. Some claim that it is difficult to learn because it's rich. There are things like you can eliminate nulls with option type, and this is idiomatic in Scala, so there is no the burden of the previous generation writing the code the different way. There are union types, match types, built-in asynchronous types, and also functional programming approach, so IO, ZIO, type class derivation, plenty more. And yeah, you can just try it yourself. There is plenty of online courses for that. If you want some direction, I can also share some links. And thank you. I guess we have some time for questions. Thank you.
Happy to pass on the mic to anyone who has a question.
Don't be shy.
So maybe without the mic. So generally speaking, Scala supports writing clean code, right?
Yes, I mean any language supports writing clean code, but you have to will for. Yeah. Yeah, but yeah, that's it. It supports writing clean code, and it provides you with more tools for writing boilerplate free code or neat, concise code. Yeah, I would argue that.